Hello, everyone, and welcome to some AP Chemistry, just in time for the weekend, I guess. And I want to talk about the things we'll be covering. Hopefully, you're all experts at naming chemical compounds by now. And if not, we'll certainly talk about that again in the fall. But we're going to talk about two topics this week. Oh, my phone's ringing. Hang on. Sorry about that. Little phone call in the middle of making a video. Uh, Looking at this, we're going to be talking about between now and next week two topics: metric and temperature conversions, as well as what's called dimensional analysis. So I'm going to take you a little further than this worksheet does, and a little bit more, well, quite a bit more in depth. So that's one of the topics, and that'll take up the bulk of our time between now and next week. And this part down here, atomic structure. Now, what I'd like you to do between now and over the weekend is just go back and see what you remember from Mr. Pearson's class about atomic structure, if anything. And as a matter of fact, let's take a little trip here and down memory lane and see if you can indeed remember any of this stuff. If I go ahead, let's see if I can make this a little bit larger. There we go. Um, if you go ahead and look at this symbol for the atom, this shows K is the potassium atom, and there are two numbers associated with this symbol. There's the 19 and the 39. And that 19 is called the atomic number. And the atomic number tells us the number of protons in an atom. So the number of protons, let me see here, is 19. The number of neutrons, this top number here, at 39, that's called the mass number. And what that is the number of protons plus the number of neutrons. So in order to get the number of neutrons, what we do is subtract the bottom number from the top number, and we would have 20 neutrons there. And if I go ahead and look at electrons, well, in the case of an atom, ooh, that's kind of crazy. I didn't want to do that. In the case of an atom, let's see if I can get back down here if it saved my changes. I guess it didn't. But anyway, of course, there were 19 protons, 20 neutrons, and the number of electrons, as long as this atom has no charge on it, the number of electrons and the number of protons are the same, because electrons have a negative charge, protons have a positive charge, and we have to have equal numbers of protons and electrons to provide us with a neutral charge. Now, if the atom has a charge, it's no longer an atom, it's an ion at that point. And if they're positively charged, they are cations. If they're negatively charged, they're anions. And if you see here, the sodium in this case, let me see if I can get back to my little pencil. The sodium here has a +1 charge on it. And that +1 charge means there is one less electron than protons. So here I've got 11 protons because that atomic number is 11, but I only have 10 electrons because that electron deficit, that one electron that we don't have, is leading to this +1 charge. So go ahead and try to go ahead and do this sheet, and let's see how much you remember. And again, don't panic. If you don't get it, get in touch with me and I'll make sure you're in good shape. So we'll get through those topics, and then the rest of the summer we'll talk a little bit about balance equations, some stoichiometry, and learning how to graph things. And I think if we get through all of that, we'll be in really good shape. So over the weekend, like I said, take a look at worksheet number 4, and next week we'll dig right into some unit conversions and go ahead and start talking about some other things. All right, have a great weekend then.